Welcome back to NUCIDA's YouTube video channel about software testing. Today, we're diving into a topic that quietly powers every great software product test environments. They're not flashy, but without them, even the best code can turn into a buggy mess. Think of building software like assembling a high-performance car. You wouldn't skip the test track before hitting the highway. Each stage of development needs its own dedicated space to ensure every part works both alone and together. This structured approach is what separates top tech companies from the rest. In this video, I'll break down the 7 essential test environments every serious software team needs. We'll cover what each one does, why it matters, and how they fit together to deliver reliable software. Whether you're a developer, manager, or just curious, this is your blueprint. Let's get started. Let's start at the ground floor, the very foundation upon which all software is built. We're going to explore a critical aspect of software development, something that every programmer relies on daily. The development environment, or dev. It's a term you'll hear frequently, and understanding its importance is key to grasping the software development lifecycle. This is every developer's personal workspace, their digital domain. Think of it as a painter's studio or a sculptor's workshop, but for code, their digital workbench. It's where ideas take shape, where lines of code transform into functional features. Here, they write, crafting the instructions that tell computers what to do. It's a process of translating human thought into machine-readable language. Test, rigorously examining their code for errors and ensuring it behaves as expected. Testing is a crucial part of the development process, catching potential issues before they impact users. And debug code in total isolation, tracking down and fixing those pesky bugs that inevitably creep in. Debugging can be a challenging but rewarding process, requiring patience and problem-solving skills. Free to experiment, to try out new ideas and push the boundaries of what's possible. The dev environment is a safe space for innovation, without breaking anything for others. It's a contained environment, preventing accidental disruptions to the wider project. The dev environment is all about speed and convenience, optimized for rapid development and iteration, loaded with each developer's favorite tools, from code editors and debuggers to version control systems and testing frameworks, and local services. These services mimic the production environment, allowing developers to test their code in a realistic setting. It doesn't need to match production perfectly. The goal isn't a perfect replica, it just needs to empower rapid iteration. The focus is on enabling developers to quickly test, refine, and improve their code. Imagine if everyone coded on a shared server. Chaos. Conflicts would be rampant and progress would grind to a halt. Individual sandboxes are essential, providing each developer with their own isolated space to work. For deep, focused work. Distractions are minimized, allowing developers to enter a state of flow and produce their best work. This is also where unit testing lives. The practice of testing individual components of code in isolation. Small, automated tests designed to verify that each part of the code functions correctly, that catch bugs early, before they spread. These tests act as a safety net, preventing errors from propagating throughout the system. The dev environment is the creative studio, the laboratory, the workshop, all rolled into one. Where every feature is born and refined, it's where ideas are transformed into tangible realities. Without it, there's no development process, just confusion. It's the bedrock upon which all software innovation is built. Every app feature you've ever used started here, conceived and crafted within a dev environment, nurtured in a developer's local setup. It's a space where code is carefully crafted, tested, and refined. It's the foundation for everything that follows. Without a solid dev environment, the entire software development process is compromised. Ensuring every developer has a solid dev environment, equipped with the tools and resources they need, is one of the best investments a company can make. It directly impacts productivity, code quality, and overall innovation. It's the non-negotiable first step. Before any code can be written, a dev environment must be established. From simple buttons to complex algorithms, from user interfaces to back-end systems, it all begins here. The dev environment is the starting point for every software project. The magic starts in dev. It's where creativity and technology converge to create the software that powers our world. Once developers have thoroughly tested their code within their individual sandboxes, ensuring that each component functions as expected in isolation, it's time to bring those pieces together and see if their code plays well together in a shared environment, a crucial step in the software development lifecycle. This is where the real magic, or sometimes the real challenges, begin. This shared environment is the integration environment. Think of this as the first team practice, like a sports team coming together to run plays after individual training. A shared space where everyone's code is combined for the first time, allowing developers to see how their work integrates with the contributions of others. It's a collaborative effort to build a cohesive system. The goal? To catch issues, dependencies, and conflicts that only appear when different parts of the system interact. These are the kinds of problems that are nearly impossible to predict in isolation. Continuous integration (CI) automates this process. Every code commit is automatically built, deployed to the integration environment, and tested here, ensuring that the system is always in a working state. If something breaks during this automated process, the team is alerted immediately through various communication channels, eliminating the all-too-common excuse of, "It works on my machine." This environment is more standardized and controlled than the dev environment, with shared databases, message queues, and other critical services. It's the ideal place to rigorously test APIs and contracts between different modules and services, ensuring that they consistently honor their agreements and data structures. Integration is fundamentally about team collaboration, shared responsibility, and overall code health, not just about individual developer productivity or isolated feature completion. It proactively prevents integration hell, the dreaded nightmare scenario of attempting to merge months of accumulated, unintegrated work right before a critical release deadline. By catching problems and conflicts early in the development cycle, the integration environment ensures that the project continues moving forward as a cohesive and well-synchronized whole. It serves as the essential pacemaker, setting the rhythm and maintaining the flow of the entire development lifecycle. Without a robust integration environment, you're essentially asking for a major disaster down the line. Integration is the first truly reliable checkpoint for assessing overall team progress and the stability of the system. It's the crucial stage where code finally proves itself capable of functioning correctly in a more realistic, interconnected environment. Now zoom out time to test the whole system in the System Testing Environment, or QA. Here the focus shifts from modules to end-to-end user workflows. The QA team simulates real user journeys, ensuring everything works together as a single product. This environment closely mirrors production with realistic data and configurations. QA testers try to break the software, uncovering bugs developers might miss. It's not just about functionality, security, usability, and other non-functional tests happen here too. Bugs found here are logged, fixed, and retested until the system meets quality standards. The system testing environment is the gatekeeper of quality. It's the last major checkpoint before users see the product. Skipping this stage risks your reputation and user trust. QA ensures you deliver a polished, reliable system. The technical teams are done, the code is written, and the features are implemented. After countless hours of development and rigorous internal testing, the software is finally ready for the next critical phase. But a crucial question remains. Does the software actually solve the right problem? Does it truly meet the needs of the end users who will be relying on it day in and day out? Are we delivering something that is not only technically sound but also practically useful? Enter the User Acceptance Testing (UAT) environment. This is a dedicated space and process designed to bridge the gap between development and real-world application. This is where real users, the individuals who will ultimately interact with the software, or business stakeholders, those who have a vested interest in its success, get to test the product themselves, putting it through its paces in a simulated real-world environment. UAT isn't about finding technical bugs, those pesky coding errors that developers typically address. It's about validation. Does the software meet user needs? Does it align with their expectations and requirements? Does it solve the problems they face in their daily work? The environment is stable and production-like, mimicking the conditions under which the software will eventually operate. But the focus is on real-world tasks and workflows, the actual processes that users will perform using the software. Users provide feedback on usability and fit, sharing their experiences and insights on how well the software integrates into their existing workflows. It's not just about technical correctness, it's about ensuring a positive and productive user experience. Discovering a major issue here, a fundamental flaw in the design or functionality, is far better than after launch, when it could lead to widespread frustration and even project failure. Stakeholders test key scenarios, simulating critical business processes to ensure the software performs as expected under pressure. They accept or reject features, based on their alignment with business goals and user needs. and request changes if needed, providing valuable input for further refinement and improvement. UAT is the final fitting, the last opportunity to tailor the software to the specific needs of its users, before the big debut, the official launch into the production environment. Without it, you're gambling on user satisfaction, taking a significant risk that the software will not meet their expectations. A dedicated UAT environment de-risks the project, mitigating the potential for costly errors and negative user experiences down the line, and builds stakeholder confidence, assuring them that the software is ready to deliver real business value. It's the last chance to align the product, ensuring that it is perfectly suited to the needs of the business and its users, with real-world needs, guaranteeing its relevance and effectiveness in the long run. UAT bridges the gap between technical success and business value, ensuring that the software delivers tangible benefits to the organization. It's a crucial step for adoption and trust, paving the way for successful software implementation and widespread user acceptance. The software works, but can it handle real-world traffic? That's what the performance testing environment is for. Here, engineers simulate heavy loads to measure speed stability and scalability. This environment closely matches production hardware and setup. Load tests, stress tests, and scalability tests push the system to its limits. Tools like JMeter generate virtual users while dashboards reveal bottlenecks. Finding issues here is a win. It's better to break things in testing than on launch day. Performance is a feature users won't tolerate lag. This environment ensures your app stays fast and reliable even under pressure. It's the proactive step that prevents outages during peak times. Performance testing guarantees your infrastructure can support your success. Almost there. Time for the staging environment, the final dress rehearsal. Staging is an exact replica of production minus real users and data. It's where you practice deployments, run final smoke tests, and catch last-minute issues. Did the migration script work? Did all services restart? Staging answers these questions safely. It's also where you debug tricky bugs that only appear in production-like setups. Maintaining staging can be costly, but skipping it is riskier. A single outage can cost more than a year of staging. Staging is your insurance policy against deployment disasters. It's the launchpad for your code, ensuring the deployment process is smooth and repeatable. Staging bridges the gap between controlled testing and the real world. It's the last stop before going live. Confidence here means confidence in production. Staging is your final safety net. The final destination, production. This is the live system where real users interact with your software. All other environments exist to protect this one. Production isn't for test scripts, but it's still a test of your monitoring, logging, and alerting. Real-time dashboards track system health errors, response times, resource usage. When issues arise, logs and alerts help the team respond before users notice. Production is a source of invaluable feedback. User behavior data drives future improvements. It's where you test your assumptions against reality. Is the system stable, fast? Are users adopting new features? Production is the ultimate source of truth. It needs constant care and observation to stay healthy. Delivering value here is the goal of every other environment. Production is where your software proves itself. There you have it. The most essential environments that form the backbone of quality software. Each one answers a different question, building confidence step by step. Skipping a stage makes a successful launch much riskier. This structure lets teams move fast without breaking things, and fix them quickly when they do. Investing in process and quality pays off massively down the line. Are these all possible environments? No, there could be even more. For instance, security testing and testing of AI applications might need additional environments to support a higher level of professional testing, or special environments for hardware or software in the loop. Thus, in terms of doubt, call the NUCIDA QA experts. What environments does your team use? Let me know in the comments, and don't forget to like and subscribe. Thanks for watching. Happy testing and see you next time.